Africa's tallest tower stands at 393.8 meters. It is called the Iconic Tower, located in Egypt's new administrative capital, about 60 kilometers away from Cairo. This city is being developed as the future capital of Egypt. The building has 78 floors above ground and 2 basement levels, making a total of 81 stories. With a height of 393.8 meters, it is almost twice the height of the Commercial Bank of Ethiopia headquarters. The total construction cost of the project is estimated at around $3 billion. Let's look at the structural system of the building. The Iconic Tower uses a core outrigger structural system, which is different from a traditional core frame system. In a core frame system, the core is located at the center of the building and is made of reinforced concrete shear walls or steel-braced frames, working together with outer columns or moment-resisting frames to resist gravity and lateral loads. However, as buildings become taller, the ability of a core frame system to resist overturning moments becomes limited. To overcome this limitation, engineers developed the outrigger system. A core outrigger system is essentially a core frame system enhanced with horizontal structural elements, such as deep beams, walls, or trusses that connect the central core to the outer columns. These elements are called outriggers, and they significantly increase the building's lateral stiffness. The Iconic Tower incorporates this system. The outer columns are composite columns, meaning they consist of steel sections, reinforcement bars, and concrete. These columns are connected using belt trusses, which are cross-shaped structural elements that brace the perimeter columns together. The building uses a composite floor system. In this system, the beams are made of steel sections, the deck consists of metal decking sheets, reinforcement bars are placed on top. Concrete is then poured to form a composite slab structural behavior. If, God forbid, the core structure fails, the building would collapse, as the core is the primary lateral load-resisting element. However, if the outer frame fails, the building may still stand because the core continues to carry the main loads. The average floor-to-floor height is 4.2 meters. During construction, the core structure was completed at a rate of 1 floor every 4 days. The outer frame was completed at a rate of 1 floor every 3 days. Foundation system. The building uses a pile raft foundation system. 375 board piles. Each pile has a diameter of 1.2 meters. Each pile is 45 meters deep. Above the piles, there is a mat raft foundation with a thickness of 5 meters. This is not a pile cap. The difference is, a pile cap distributes loads from a single column to a small group of piles. A raft mat foundation covers all piles and works as one structural element. In this building, the raft carries about 25% of the superstructure load. The piles carry about 75% of the load. A 5-meter thick raft is extremely significant. It is about double the thickness commonly used in many high-rise buildings in Ethiopia. Total floor area, 265,000 square meters. Material consumption, for foundation, 37,585 cubic meters of C45 concrete, 5,000 tons of reinforcement steel, for entire building, 180,000 cubic meters of concrete, 18,000 tons of reinforcement steel, vertical transportation and facade, 54 elevators, 4 escalators. The building uses a double-skin facade which plays a major role in thermal insulation and reducing cooling loads. Seismic design and codes. Designed to resist an earthquake of magnitude 8 on the Richter scale. Concrete Design Code, ACI 318. Project Team and Timeline. Architectural and Structural Designer, Dar al-Handasa, Lebanon. Main Contractor, China State Construction Engineering Corporation, CSCEC. Construction started, 2018. Construction completed, 2024. For more engineering content like this, join our Telegram channel. The username will be shown on the screen.